Hello everyone, today we are going to analyze the functional group present in these organic compounds. Functional groups are specific groups of atoms that determine the chemical properties and reaction of organic molecules. By identifying these groups, we can predict how the compounds behave in different chemical reactions. Let's begin with the left side of the structure. The first function groups we can see is an alkene bromide, also called as haloalkene. It is identified by the bromide atom attached to a carbon atom. Alkene bromides are quite reactive because the carbon-bromide bond can easily be broken, allowing bromide to be replaced by other atoms or group in substitution reaction. Next, we observe two alkenes group, which contain carbon-carbon triple bonds, written as C with a 3 line and C. Alkynes are unsaturated hydrocarbons and are more reactive than single bonds because of their multiple bonds and commonly undergo addition reaction and are useful in organic synthesis. Moving toward to the center of the molecule, we can find an alcohol functional groups. This is the hydroxyl groups or negative OH attached to the carbon atoms. Since it is attached to a carbon connected to two other carbon, it is classified as a secondary alcohol. Alcohol can form hydrogen bonds, making them more soluble in water than similar hydrocarbon. They also participate in oxidation and esterification reaction. Another important functional group is the ester. We can identify it by the patterns of COO, whereas carbonyl groups is connected to an oxygen atom. Ester are commonly found in natural fats, oils, fragrances, and flavoring. They are usually formed from the reaction between an alcohol and a carboxylic acid. Now I will pass it over to my partner to explain the remaining functional groups.
Thank you. Now let's take a look at the rest of the molecule. First, we can identify three alkaline groups. An alkaline contains a carbon-carbon double bond. One alkaline is next to ester group, other is in the middle of the carbon chain, and the last one is at the end of the chain. Alkynes are understraight compound, so they can easily react to other substances through addition reaction. Next, we can see Bunsen ring, which is also called aromatic rings. This is made of 6 carbon atom argons in a ring with alternate double bond. Bunsen ring. Bunsen rings are very sustainable because electrons are shared around the rings. They are commonly found in the medicine, plastic, dyes, and many natural compounds. Attached directly to the Bunsen ring is a hydroxyl group called phenol. A phenol is similar to an alcohol because it has OH group but has different properties since the OH group is attached to the Bunsen ring. Phenols are more acid than alcohol and are often used in disinfectants and antioxidants, and also plastic pollution. To summarize, this molecule contains 1 alkaline bromine, 2 alkaline groups, secondary alcohol, 1 ester, 3 alkaline groups, 1 aromatic benzene rings, 1 phenol. Altogether, the molecule has 10 individual function groups, or 7 main types of function group. If alcohol and phenol are constant separate. In conclusion, this compound contains many different function groups. Each function group gives the molecule different physiology and chemical properties, so it can take part in many kinds of chemical reactions. Thank you for listening. We hope this presentation will help you understand how to identify and analyzing function group in organic compound.